Hi everyone, I'm Peter. In today's video I'm going to show you how you can encrypt and decrypt any file you want in Python using the AES algorithm. AES is unlike RSA, a symmetric encryption algorithm, which means it uses the same key for encryption and for decryption. Okay, let's start. We start by importing the crypto library. And we're gonna make it simple for the first example, and we're gonna encrypt a simple text, a simple string, and we're gonna call this string plain text, and we're gonna give it a value as AES works on a block size of 16 bytes. We have to extend this text so it reaches 16 characters. We do this by something called padding, and it is adding characters so it reaches 16 bytes or 32 bytes or 48 bytes, so a multiple of 16. We're gonna write a function for this, and we're gonna call this function pad, and it will take the original text or the original string as an entry, and we pad it will be the original one plus some extra characters. I will explain this later how I get to it. And we're gonna add square brackets as the padding, and we're gonna return this value. And we're gonna work with the padded value of the plain text. Now let's run plain text equals. Okay, let's run this. So now we will see plain text is the original text added with some square brackets. The 16, how do I get to it? 16 is the AES block size, and you can find it by this. So it is 16. And now the formula. So the original text added by the square brackets. So we use 16 minus the length of the original entry and mod 16. So let's say the original text is 15 bytes. So if we do 15 mod 16, it will give you 15, because 15 is the leftover of 16 multiplied by 0. So the 16, the AES block size, minus 15 is 1, so we have to add 1 square bracket. We're gonna use 1, 2, 3, 4, 5 as the encryption key or as the password, and again we're gonna pad this. As AES works on byte level, we have to convert all these strings to bytes, and we use this using the encode UTF-8 command. And we're going to do the same for plain text. So if we run this, you will see the key is a byte and the plain text also will be a byte. So you can find it, the type of it. Key is bytes. Okay, now we have this. This is the start. Now we need a method so we can use it to encrypt our messages, and we're gonna call this method cipher. And cipher is AES, a new method, and it uses the key and the mode we're gonna use. And here for this example, we're gonna use ACB mode. And just for demonstration purposes only, because normally you shouldn't use ECB mode because it is insecure. In the next part I will use a different mode, but now for now just for demonstration purposes only. So now we have this method. We can use this one to encrypt our message, and we're gonna call our encrypted message ciphertext, and it will be, and using this method to encrypt it. And we're gonna encrypt plain text. So now we can print out this encrypted text. Okay, and now try this. So here you can see this is our encrypted text. So it's completely different than the original one, Bali is paradise, which it is. So now we're gonna decrypt it, and again, for decryption we use, or we will create a new method for decryption, and we're gonna call it cipher2, and it's exactly the same as the encryption. So cipher2 will be AES dot new, and again we're going to use the same key and the same mode. And now we're going to decrypt our ciphertext, and we're going to call it data, and data will be okay. Let's run this and see what it will give. And if we now print our data, so the data is still in byte format, and it still has those brackets, the padded brackets. So we're gonna remove it, we're gonna put it back to a string instead of a byte, and we do that by decoding it instead of encoding it. Here we encoded it to a byte, and now we're gonna decode it from a byte. Using again UTF-8. So we have converted it to a string, and now we have to remove the brackets. How do we remove the brackets? Or first we find out how many brackets they are, and then we're gonna remove them. So unpath will be find all the brackets. So here we have 1, 2, 3, 4, blah, 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 let's say 7 brackets. This one unpath finds the, will give 7, so 7 brackets. And now write the string without the brackets. So data will be, and only write until the brackets. And now print it out, decoded text equals data. So let's say unpad, that's the amount of brackets, is 7. We're gonna write our string until we find the bracket. So the brackets is on position 9. It will write only until position 9. So now if we run this, decoded text is the same as the original text, which was the purpose. So now run it again. This is the original text and we used the same key for it. So this was the simple part. Now the next part will be encrypting and decrypting a file. It can be a text file, a Word document, an Excel document, a picture, whatever you want. Now we have encrypted and decrypted a simple string. Now let's go over to the real stuff, namely encrypting and decrypting files. Again, we start the same as before. And we're gonna encrypt a file called tests.txt. That's a simple text file I've created already. We are in the year 2020, exclamation mark, and Bali is paradise, which is so true. So this is a file we're gonna encrypt, and we're gonna write a function for this called encrypt. And we're gonna encrypt this file. Okay. Let's start with the key. As you did see, we do need the key for the encryption, and this time we're gonna use a password for this key. Please insert your password. And again, we have to convert it to bytes. We already know how to do it. And as in our previous example, we have to pad it, but to make life easy, we can import something from the crypto library, so we don't have to write this function ourselves. So we're gonna import it. And we're gonna use it. And this one we will use in our function too. So now let's write our function. And this function uses the text file and our key. So file name and key. Let's make it easy. Okay, now we're gonna open and read this file. And we're gonna read it as bytes, and let's call it entry. So now the data we are going to work with will be the things we read from this. And again, as in our previous example, we have to create a method to encrypt this. So you've seen it before, AES.new, using the key and the AES mode. CFB. This time we're gonna use the mode CFB, which is a different mode than before. The difference is it uses another parameter called the IV, initialization vector. The initialization vector, that's an arbitrary number that is used along the secret key for encryption and decryption. It makes it more secure and more difficult to hack it. So let's say it adds an extra layer of security to it. If we don't create the initialization vector ourselves, the AES algorithm creates it for us. And this vector is needed to decrypt our message. So it needs to be sent together with our encrypted message. So we have already created our method and use this method to encrypt our message, and our encrypted message will be ciphertext, will be cipher.encrypt our data. Aha, I forgot it. We have to pad this the same as we did with our key and with the length of the AES block size. Okay, now we have this. Because now we have to write the initialization vector and the ciphertext together. We have to put it in a more readable format and normal letters, let's say, and therefore we use the base64 library, which can do that for us. So we're gonna import this one too from base64, import b64 encode. Okay, now let's use this one. So the initialization factor will be b64 encode cipher.iv. Here the initialization vector will be created. That's the one we will need to decrypt our message, and we're gonna decode it using UTF-8, and we're gonna do the same for our ciphertext. B64 encode our ciphertext, and then decode it using UTF-8. Okay, so now what we are going to send is the initialization vector together with the ciphertext. So we're going to write this one to a file. So what we will write will be IV plus our ciphertext. So now we have everything from the encryption part, so we can close this one. So entry.close, and now we can write it to our encrypted file again with open, and we're gonna write it to a file with the .enc extension, encrypted extension. So with open file name, and we're gonna give it a new extension, and we're gonna write as data, and now data dot write, and we're gonna write our to write. Make it simple. This should work, and now we can close this. Data not close, and normally this should be our encryption part. So now let's try this and run it. Yeah, 7. Okay, I forgot it. I'm sorry. Okay, try it again. File name is not. Okay, mistakes are easily made. So now it seems to be working. So now let's check what has been done. So it has created a new file called test.txt.enc, and now if we open it, this is our encrypted text. For decryption it is very similar, so we're gonna copy this part. I made some modifications. We also need the unpad function, and we need the decode function, not the encode function, so do it the other way around. And first we need our key. So as we did before in our previous example, the encryption, we did type the password, and every time we typed the password it was visible. So this is not very safe. So we want to hide it when we type our password. Therefore we're gonna get the getPass library. So we're gonna import this one too. And we're gonna get our key, and the key will be getPass dot getPass. Please enter your password. And again we have to pad this and put it in byte mode. So key will be key dot encode UTF-8, and again we have to pad it with the AES block size. Okay, now we have this, we can start with the decryption. And we're gonna use the same file name. And we're gonna read it as the entry. So the data we are going to work with will be this, the content of this file. So try data will be no. Let's see our encrypted text file. The initialization vector is this part, and our encrypted message is this part. So how are we going to find this part? It's always 24 bytes, and this part, okay. So first find our initialization vector. So the length is the length of our string. Len data. So our initialization vector will be the first 24th characters of it. And now we have to decode it using the base 64. B64 decode IV, and our ciphertext will be the remainder of our text. Ciphertext is data from 24 till the end. And again, we do the same. These 64 decodes. Ciphertext. Okay, and again, as many times before, we need a method to decrypt it. So we're gonna create one. Cipher dot no AES dot new. That's the key we have and the AES mode. It was CFB. And here what comes into game, the initialization vector, so we need it. So we can use this method to decrypt our message. Decrypted will be cipher dot decrypts our ciphertext. And now we have to work the other way around. We have to unpad it. Unpad decrypted with the AES block size. AES block size. And now we have to write our encrypted file to a new file. And we're gonna do that. First we close with open. We're gonna give it a new name. Oh no, what we can do is we can delete this one and create a new one. As data, and what are we going to write? Data dot write will be decrypted. And now we can close this. And now finish our try statement. Wrong password. So now let's see if this works. Okay, something stupid. Here you see, I use Spider as a console, but the get pass is not working here, but believe me, it is working on another IDE. So everything should be normal. Let's see. And here we have our original text back. And if you don't believe me, So now we're gonna run it like this. Run. Please enter a password. Azarti. Now you cannot see it, but it has been created. Look at the text. Okay, we're gonna try it on a picture file. So I have this one to try it with. So we're gonna encrypt it. File. The name is test.jpg. So test.jpg. We're gonna encrypt it. I'm gonna give it this password. So now it is encrypted. We can open it using Notepad. And as you can see, this is it. Okay, and now we're gonna decrypt it. Test.jpg. Oh, GPG. Not encrypt. We're gonna call it decrypted.jpg and see if it works. Okay, stupid. Run this again, enter the password. Decrypted.jpg. Yay! And there it is again. I hope you enjoyed this video and that you did learn something. If you have further questions or any questions, please ask in the comments and I will answer you. Enjoy the rest of your day. Have a nice day. Bye. See you in the next video. Bye.